Assalamu alaikum. Today we are going to discuss the different methods how to balance the chemical equations. There are around about four methods to balance the equations: inspection method, algebraic method, oxidation number method, and ion electron methods. But mostly last two methods are used: oxidation number methods and ion electron methods. These both methods are used for the redox reactions. Oxidation number method is also used for redox method. Ion electron methods is also used to balance the redox reactions. The basic difference in the both methods is that oxidation number method is used only for the redox reaction, but it doesn't bother about the solutions, whether it's aqueous solutions, whether it's acidic aqueous solution or basic aqueous solutions. But ion electron methods, basically that method is used for balancing of redox reactions. Aqueous media may be acidic aqueous media, maybe basic aqueous media. There are the different methods to balance the equations. But these both well-known methods are mostly used to understand the basic principle of both methods, oxidation number methods and ion electron method. We must know about the oxidation states, first of all, of the elements in the periodic tables. For example, you must familiar with the oxidation states of the elements in the periodic table. For example, group 1 of the periodic table, that is belong to the alkali metals: lithium, sodium, potassium, rubidium, cesiums. These are all metals. We know that metals have a tendency to lose electrons, and they have a tendency to lose one electrons. So oxidation states or oxidation number of all alkali metals are +1. They show +1 oxidation state in all their compounds. And other ones, group 2, that is alkaline earth metals, they are mostly show the oxidation states +2 in all their compounds. The example of beryllium, magnesium, and calcium. Similarly, group 3, in which most well-known elements, aluminium, show +3 oxidation states. These are those oxidation states which can never be changed and must be remembered by any intermediate level students on the fingertips. And other elements which belong to group 1, that is a hydrogen not a metal, basically non-metal. So non-metals may show oxidation state +1 and -1. So hydrogen show the oxidation state +1 when it combined with the non-metals, and hydrogen show +-1 oxidation state when it combined with the metals. For example, metal hydrides, lithium hydrides, sodium hydrides, and calcium hydrides, etc. And other elements which have a permanent oxidation state. Most common oxidation state shown by the halogens. Fluorine, chlorine, bromine, and iodine, they mostly show -1 oxidation state because these are the non-metals. Similarly, common oxidation state of -2 belong to the oxygens. Normal oxides, oxygen compounds of the oxygen are oxides, and they show the -2 oxidation state in normal compounds. But other compounds of oxygens are there. They are the peroxides, superoxides, but in their compounds, for example, hydrogen peroxide, for example, some potassium superoxide, they don't show -2 oxidation states. We only talk about their normal oxidation states. They are showing in their oxides -2 oxidation state. Okay. Next, uh, if you remember all oxidation state, you can find out the oxidation state of unknown element in the compounds. If you know the familiar oxidation state, well-known oxidation state of the elements, maybe alkali metals, alkaline earth metals, halogens, oxygens, and etc. For example, zinc chloride. We're going to zinc chloride. What is the oxidation state of zinc? Zinc is the belong to the transition metals. We know that transition metals, they have a more than one oxidation states, and we don't know what is the oxidation state of that element in the compound. They may vary the oxidation states in different compounds. For example, zinc chloride, we don't know the oxidation state of zinc, but we know the oxidation state of chlorine. Chlorines belong to the halogens. All halogens show -1 oxidation state. For example, chlorine is -1 here. There are the two chlorine -2, and zinc have a +2. One thing. For if you have a neutral compound, for example, zinc chlorides, you must put the oxidation state plus and minus. In that way, the answer of the all oxidation state of plus minus must be 0. In the neutral compound, for zinc chlorides, zinc have a +2 oxidation state, chlorine have a -1, 1 chlorine and 2 chlorine -2. So -2 and +2 is equal to 0. Okay. Next, sulfur trioxide. Sulfur trioxide, the oxidation normal oxidation. We know that oxygen have a normal oxidation state of -2, but sulfur have not a permanent oxidation state. It may show +6 oxidation state, it may show -2 oxidation state. The elements which have a variable oxidation state, we can determine of that elements which have a variable oxidation state by those elements which have a common oxidation state and well-known oxidation state. For example, oxygen a -2 oxidation state, sulfur trioxide, one oxygen -2, 3 oxygen -6 and +6. So it means sulfur have a +6 oxidation state. And other one is the basically that is the nitric acid. What is the oxidation of nitric acids? Oxidation state of nitric acid. Hydrogen have a oxidation state +1, oxygen have a -2. There are the 3 oxygens, and 3 and 2 plus -6 +1, and we put the oxidation state on the nitrogen +5 +6 +1 +6, and -2 multiplied by 3 -6, -3 plus -6 and +6, that is 0. Next is the dichromatines. Dichromatine, basically they have already -2 oxidation state. To find out the oxidation state of the chromium, what is the oxidation state of this chromium? We don't know, but we know about the oxidation state of oxygen. We have some formula. For example, chromium is unknown oxidation state. We suppose it as X. There are the 2 chromium, so with 2x plus there are oxygen, there is 7 oxygen, 7 multiplied by -2, that's the oxidation state of oxygen is equal to -2. After the equals, we put the oxidation state of the ions. If any compounds, if the neutral, we put the 0. If any ions, we put that oxidation state with same sign. Okay, that is -2, and we solve it. When we solve it, the value of X is +6. It's mean dichromatines oxidation state of one chromium ion is +6. That's all. I think you got my points. In next video, we will discuss the oxidation numbers and for more compounds in the redox reactions. Thank you very much.